Drishti satellite latest news. Indian space startup Galaxy launched its first satellite Drishti aboard a SpaceX Falcon 9 rocket from Vandenberg Space Force Base, California, as one of 45 payloads on the Ka 500-2 mission. Founded by IIT Madras alumni, Galaxy has created the world's first satellite capable of capturing optical and radar images simultaneously of the same location, a technological first in space imaging. Space imaging. Space imaging refers to the collection of visual and electromagnetic data from space, used to map celestial bodies, track cosmic phenomena, and monitor Earth's environment. This technology translates data from across the electromagnetic spectrum into high-resolution imagery. Key technologies. Optical sensors capture visible light to produce detailed, high-resolution photographs of Earth and deep space objects. Synthetic aperture radar, SAR emits microwave pulses to map terrain. Because it doesn't rely on sunlight, it can image through clouds, smoke, and total darkness. Infrared and thermal imaging detects heat signatures, which is essential for studying star formation in deep space and monitoring wildfires or climate patterns on Earth. Hyperspectral imaging breaks down light into hundreds of narrow bands, allowing scientists to identify the exact chemical composition of minerals, vegetation, and gases. AI and cloud computing. Modern space systems utilize artificial intelligence directly on orbit to process petabytes of imagery instantly, enabling real-time change detection and analysis. Limitations of existing imaging technologies. Space imaging satellites currently use one of two technologies. Optical/multispectral imaging works like a normal camera, producing clear, intuitive, and easy to understand images. However, it is ineffective during cloudy weather or nighttime, a significant limitation for tropical countries like India where cloud cover is frequent and unpredictable. Synthetic aperture radar, SAR, uses radar signals that can penetrate clouds and capture images continuously regardless of weather or lighting conditions. However, SAR images are not intuitive like X-ray images. They require trained experts to interpret the data, limiting their usability for general users. The gap-Y fusion is needed but difficult. Users currently need data from multiple satellites, optical data for clarity and SAR data for continuity and all-weather availability. While superimposing these two datasets often works, it has serious limitations. The two satellites are not watching the same place at the same time, and the angles at which they observe Earth can be very different, making accurate data fusion a persistent challenge. What makes Drishti unique? The Opto-SAR technology. Drishti is the world's first satellite equipped with both optical and SAR sensors operating simultaneously to capture images of the same location at the same time. Galaxy calls this proprietary innovation Opto-SAR technology. The core technological challenge and how it was solved. SAR and optical sensors are designed differently and look at Earth at different angles. If placed side by side without synchronization, the optical sensor might be capturing Bengaluru while the SAR sensor is simultaneously capturing Dubai. Galaxy developed a proprietary technology stack that synchronizes the functionalities of both sensors, enabling them to look at the exact same location at the same time. Hence, it eliminates the need for users to manually align datasets from two different satellites. The AI dimension. When optical sensors are unable to capture images due to clouds, Drishti uses artificial intelligence to regenerate optical-like images from SAR data, further bridging the gap between clarity and all-weather reliability. Why this problem is particularly Indian. Most traditional satellite companies are based in Western countries where weather is relatively more predictable and skies are cleaner. They do not face the same intensity of cloud cover challenges that countries like India located in the tropics routinely experience. Galaxy is therefore solving a problem specific to India and the developing world, making space imagery available all the time and understandable to all kinds of users. Applications of Drishti. The data produced by Drishti has both civilian and military applications, including agriculture monitoring, disaster management, urban planning, infrastructure monitoring, border surveillance, and defense intelligence. India's growing space startup ecosystem. Galaxy is part of a rapidly emerging wave of Indian private space companies making significant technological contributions. Other notable startups include Agnikul Cosmos, IIT Madras, which built the world's first 3D printed rocket engine, Skyroot, which tested India's first privately built rocket, and Pixel, Dhruva Space, and Bellatrix, demonstrating impressive innovations in satellite technologies. This ecosystem has been significantly enabled by India's Space Policy 2023, which opened end-to-end space activities to private players.